and standard deviation. So you guys are going to learn how to find variance and standard deviation of data. Okay, so let's talk about the two and what they mean. Okay, variance combines all of the values of your data set to produce a measure of spread. In other words, how spread out your data is. Okay, it is the arithmetic mean of the squared difference between each value and the mean value. Okay, so when we go through, we actually do variance by hand. You'll see that we're actually going to end up subtracting values, squaring them, and then finding the mean of them. Okay. Now, squaring the difference between each value and the mean value has three advantages. Okay. First off, when you square a number, it makes each term positive, so the values above the mean do not cancel out with any values below the mean when we go to adding them together. Okay, so that's one advantage. Also, it adds more weight to any large differences. Okay, adds more weight to any large differences. So let's say that one of your values was like really small, and when you subtracted, it gave you a really large number. Well, you're squaring a larger number. But by squaring other smaller differences, it pretty much makes things a little bit more even. All right, and then of course it makes the math relatively manageable because now we're only dealing with positive numbers and not negative numbers. Okay. Now, standard deviation is the square root of variance, okay? And it has the same units as your mean. Or sorry, it has the same units as your data. So if they ask you what's the standard deviation of particular data, you would say 2.5 volts or whatever, okay? But standard deviation shows how much variation there is from your mean and gives an idea of the shape of the distribution, okay? So standard deviation shows you how much your data is spread out from the mean. Okay, and low standard deviation means that your data will be very, very close to the mean, but a higher standard deviation means that your data will be more spread out over a larger range of values. Okay, so what does that mean to somebody who's looking at like analyzing data? For example, Mr. Saran, who's always collecting data, trying to see, when it comes to like scores on tests and things like that. If there's a low standard deviation, that basically means that all the students scored around the same number. Now, if that number is a good number, then that's a good thing, because then that means that everybody was kind of around the same level. But when there's a higher standard deviation, that means the grades were more spread out, which means there was some inconsistency somewhere. He figures that out, reports to us, and then that kind of helps us be like, okay, well, where were we lacking, and we can improve from there. All right? What that looks like here is what you see. That's a normal distribution curve. This is usually where you see standard deviation the most, okay? Again, a low standard deviation. Again, it'll be a thinner curve because, again, all your data points will be closer together. A higher standard deviation is more fatter because it's spread out more, okay? Different properties of these. Standard deviation is only used to measure spread or dispersion around a mean. Okay, nothing else. Standard deviation is never negative, which means that when you work it out, if you end up getting a negative number, that means you probably did something wrong. Maybe you forgot to square a particular value at a certain point, okay, but it should never be negative. Plus, can you take the square root of a negative number? No. So then that, if you get an error message on your calculator or something, that lets you know that, okay, something is wrong. Standard deviation is sensitive to outliers. So if you do have a value that's far from the rest of your data, it is going to affect your standard deviation because that number is so far away from the mean, it's going to cause the spread to be higher because of that one value. Does that make sense? Okay. Let's see, for data with approximately the same mean, the greater the spread, the greater standard deviation. We talked about that. And then, of course, if all values of the data set are all the same, then the standard deviation is 0, because that means that each x value will be equal to the mean. Okay? So if you have 10 people in the class and they all scored a 75, the mean is going to be and the standard deviation is going to be 0 because there's no spread. Everyone literally got the same grade. Okay? All right. So, how do constants affect your standard deviation and your mean? We're going to talk about that next. Okay? How it affects it. if you add or subtract a value to or from all the numbers in your data set, then the mean increases or decreases by that value, but the standard deviation remains the same. So, for example, let's say you're given 50 pieces of data. Actually, make it more realistic. There's 25 of y'all, right? I go through and I grade your test. But I get to that very last person and I realize, oh snap, I graded number 3 wrong. Now I have to go back and award everybody 2 points. Okay? Instead of going back and saying, okay, well the mean originally was a 82, instead of going back and adding up all 25 of the scores and dividing by 25 to get the new mean, I can just take the score of 82 and add 2 to get 84, my new mean. So it saves you some time. Okay, so the mean is affected by that constant. So if I have to add 2 more points to everybody's test, that means I just add 2 more points to the mean. The standard deviation does not change. The spread did not change. Everybody got that increase. However, well then I actually have to go through, or I only do it to the 10 who do that change, and I only affect it with that 10. Now, if you multiply or divide the numbers by a constant, then the mean and the standard deviation are both changed. So you either multiply or you divide. Okay? And there is an example that's on your paper of where this plays, where you see this happen. Yes?
So then is sigma the note for standard deviation?
Yes. This is the symbol for standard deviation. It's like a circle with an extra tail at the top, not to be confused by this. This one here means theta, represents an angle. It is literally off the top. Okay? So there's a difference between the two. And then the X with the bar, that means mean. Have I talked about this?
Yes.
Okay. So this could either be mean or what's the other symbol for mean? The Greek letter, yes. Very good. All right, so then this example says the set of data has a mean of 20 and a standard deviation of 6. So whatever they collected, the mean was 20 and the standard deviation was 6. Each value of the data set has 10 added to it. You have to write down the value of the new mean and the new standard deviation. Remember, write down means what? What does write down mean? It's little to no work, okay? So that means either the answer is staring you in the face, or you have to do very little work to get it. So remember, 10 represents a constant, and it's being added. So when you add a constant you add it to your mean. So what's the new mean? 30. Because it's just 20 plus 10, so that's how you get 30. And the standard deviation stays the same, it does not change. Okay? So those example, write down. Little work for part I, no work for double I. Now it says each value in the original data set is multiplied by 10. So remember, when it's multiplied by 10, the data set, what happens to the mean? It gets multiplied by 10 as well. That requires little work as well. So then we're going to do 20 times 10, which is 200. Okay, so that is our new mean. Then it says find the value of the new variance. Okay, find the value of the new variance. How is variance and standard deviation related?
Standard deviation.
Say it again, Bodie. Variance is the square of standard deviation, because standard deviation is the square root of variance. So you go backwards. So variance is the standard deviation squared. So then if I can figure out what my new standard deviation is, I'll be able to figure out what my new variance is. You multiply your standard deviation by 10. So I'm going to take 6. I'm going to multiply it by 10. That gives me what?
60.
But then to find my variance, I have to square that. And so what's 60 squared? 3,600. Okay? You guys just did a question 6 from an old IB exam. All non-calculated, if you noticed. Okay. Easy 6, yep. Should be easy 6. You just gotta remember, this is where, if anything from this particular year, I remember this is the question that tripped students up because they forgot that variance was standard deviation. Questions? So, let's find actual standard deviation. We are going to do it by hand first. That's what the table is there for. And then I'll show you how to do it in your calculator. For exams and for tests and quizzes, I expect you to know how to do standard deviation by your calculator. But if you decide to do your internal assessment on statistics and standard deviation is one of the things you use, this is how you would do it by hand. Okay? So, 30 farmers were asked how many farm workers they hired during a typical harvest season, and these were the responses. We're going to calculate the mean and the standard deviation. So, what we need to do is we need to make sure that we put all of our x's in a table. And what do you think F stands for?
Frequency.
Frequency. Because if we have 30 pieces of data, don't some of these pieces of data repeat?
Yes.
What's our smallest data value?
0.
Do I have a 1?
Yes.
A 2?
Yes.
Do I have 3, 4, 5, 6, 7?
Yes.
And an 8? And I'm guessing a 9 as well, huh?
Yes.
Cool deal. Go ahead and complete my frequencies for these x values as well. How many zeros? How many ones?
1,
How many twos?
2,
3,
3,
4,
6,
5,
5,
6,
4,
7,
3,
8,
3,
and 9.
2.
Okay? I can always double check to make sure you guys did this right because all of my frequencies should add up to equal what? 30. So this becomes 4, 7, 13, 18, 22, 24, and 6 make 30. Okay? So now, this chart here is laid out for you to help you get to the point where we can actually figure out our mean and our standard deviation. So we'll stop at a certain point to find our mean, and then we'll continue the rest of the table to find our standard deviation. Okay? So to find our mean, we do need to multiply our frequencies and our x values together. And then we're going to need to do what to this column? Add them up. Okay? And once I've added up all of my frequencies and my x values, I'll be able to divide by my total frequency to get my mean. So, let's multiply this here. 1 times 0, 1 times 1,
1,
keep going.
4, 9, 24, 25, 24, 21, 24, 18.
Okay? And I'll give you guys a few more seconds to go ahead and add up all those numbers. What was your total? 150. So then to find my mean, I would take the sum of all of my frequencies times my x values and divide it by my total number of frequencies. So that's 150 divided by 30, and my mean is 5. So the average number of farmers that were hired during the typical harvest season would be 5 people, or 5 workers. Now we're going to complete the rest of the table to find my standard deviation. Okay? The formula for standard deviation, if you were to do it by hand, is the sum of all your frequencies multiplied by the difference of your mean and your x value squared divided by your total number of data points and then the square root of that. So in other words, we need this last column. We need the total. We're going to divide by n, which is my total frequency, and then take the square root of that. So let's subtract my x's from my mean. So that's my original x value subtracted from my mean, which was what again? 5. So then this will be negative 5, because it's 0 minus 5. Negative 4. Negative 3, negative 2, negative 1. Nicely, these numbers are just increasing by 1, which is causing the difference between those and my mean to go in a nice sequential order. What's negative 5 squared? Remember, you always work with positive numbers here. So I have no more negatives. 4 squared, negative 3 squared, 2 squared, 1 squared, and 0 squared. Now from here, I need to take that column where I subtracted my mean from my x values and squared it, and then multiply it by my frequency. My frequency is over here, the second black column. 1 times 25, 1 times 16, 2 times 9, 3 times 4, 6 times 1, 5 times 0, 4 times 1, 3 times 4, 3 times 9, and 2 times 16. Now I need to add up that entire column to get the numerator of my standard deviation formula. All right, so we get a sum of 152. So then to find my standard deviation, which I'll do real small over here, it's going to be 152 divided by 30, and then we're going to take the square root of that. Now at this point, considering that we are going to be using our calculators in the next few seconds, go ahead and pull your calculator out, divide 152 by 30, and then take the square root, so we can find our standard deviation of workers. Now, standard deviation, you want to make sure that you round the 3 significant figures. What'd you get?
2.25.
So it'll be 2.25 workers. Okay, that's a small standard deviation. That means it wasn't like someone hired 25 workers for a harvest season, pretty much all around the same. Okay? Questions on how to do it by hand?
This is the only time.
Unless you decide to do a statistics-based IA and use standard deviation as one of your mathematical processes. That's if you decide to choose. Some students like statistics as a concept, and so they want to do an internal assessment that is statistics-based. When you are doing this using your calculator, you want to make sure, this is how you'll do it for any exams, tests, quiz, okay? We are dealing with statistics, so you want to make sure that you go to the statistics button, stat. It's located 2 buttons to the right of your alpha button. This screen should come up, and you want to go to edit. Edit is where you'll go to type in your list, basically your raw data, okay? Now, you can either type in your original raw data, all 30 pieces, into L1, or since we did create a frequency table to do it by hand, you could type in the condensed X values into L1 and then your frequencies into L2. Does it matter? It does when it comes to what we do after we type in our data, okay? So let's go ahead and let's do it based off our the frequency table. So you'll do an L1. Raise your hand if you have data already in your calculator. Okay. So this will happen, especially since this class and other classes are doing statistics. To clear out any data that's already in your tables, you'll go up to L1. So I just press the up arrow until L1 is highlighted. You'll click clear and you'll click enter. That's how you'll clear out all the data in L1. And the thing is, you don't want any extra data underneath all your new data. So just go up to the column title, hit clear, hit enter, and it'll clear everything out. Then you can begin typing in your new data. So 0, enter, 1, enter. You press enter after every entry. So in that way it registers into the calculator, including that last value. Then you'll click the over arrow and then you'll type in your frequencies into L2. So go ahead and do that. Okay? I make a mistake, all you have to do is just go back up there, and then, unfortunately, just have to go back through. 3, 32. Does my table look right? All right. Is everyone up to this point?
Yes.
Cool. All right, so press second mode. That exits you out of your program. You go back to stats, and you want to go over to calc. Calc has all these different types of operations. We'll use a few other ones inside of this unit. For this particular purpose, we want to go to one of our stats. One of our stats stands for one variable statistics. We're only dealing with one variable here, the number of farmers hired to work this harvest season. Okay? Now, raise your hand if your calculator does not look like mine. And it's the same brand. We're good? Okay. All right. So, list. List represents your X values. Okay? Like, what are you talking about? What are you listing? We were listing all of the farmers that were hired. So, that's always L1. Okay? Everyone has an L1 right there?
Yes.
Okay. If your frequency list is empty, like mine is, I actually have to type in my frequency list. So to do that, I press the second button, then I press the 2 button. What that does is it pulls list 2 and lets the calculator know that, hey, list 2 was where I put in all my frequencies. I will only have something in frequency list if I have a frequency list. Okay? Remember how I was saying we can type in all 30 pieces of our raw data? If I did it that way, I would only have something in L1 and nothing in L2. So then frequency list would need to be empty. So then I go down to calculate, I click enter, and then you have all this information right here. X bar, wasn't that what our mean was?
Yes.
There's the symbol. Do you see the symbol for standard deviation?
Yes.
It has an X attached to it, but that's because it's doing the standard deviation of our X values. But it's right there, the 2.25. That's what we got when we did it by hand. Okay? Some other information that's given to you. You have your pieces of data. There were 30 farmers that were asked. We have our minimum value. We even have the information for our box and whisker as well. So all of that's there as well. You can do this for any calculator problem when it comes to like the box and whisker. Okay? You can do that here as well. But you go to, once all your data's in, you go to stats, you go over to calc, 1 bar stats. Yes?
Yes.
Okay.